All right, hello everybody. Today we are on day 2 of Unit 6, our Analytic Trigonometry unit. Today we are going to start doing our trigonometry proofs. So it's going to be kind of a weird video. It's mostly me going through examples, but I think that's really just the best way to kind of understand what's happening here. So we're going to go over the steps for how to do a proof in trigonometry, and then I'm going to do a couple examples with you guys. So let's go. Okay, so this is actually just the top part of your homework that you're going to have tonight. So these are like our notes for proofs. Okay, so there really isn't any notes. There's not really that much to kind of write down, but we are going to kind of go through this and talk about what we're doing. So when we do a proof in trigonometry, you can kind of think of this a little bit like when you were doing proofs in geometry, where you had that like 2 columns, and you would like, one column was where you would write down the different properties you use, and then like the other column, if I can talk, was like where you kind of wrote like your steps. The only difference is that we are only writing the steps. So when we're doing our proofs in trig, so we have an equation. All right, so if you look down at number 1, you can see that we have 2 sides. Our goal is to take one side of the equal sign and use properties and different rules to convert it to look like the second side. All right, and that's our goal. All we're doing is using properties and algebra to get one side of the equation to match the other side. So we're trying to prove that this equation is true, and they will always work out. So if you see one of these problems in my class where we have an equal sign, I'm saying that they are equal, prove it. All right, so the important part is you can only work with one side of the equation at a time. You can't flip-flop. We're not solving. So we're not going to move pieces from one side to the other. That's something that people try and do, and that is wrong. One side of the equation you will leave exactly as it is, and you're just manipulating the other side. So the first step is to choose the side of the equation that you wish to work on. Generally, this is going to be the more difficult looking side, because it's always easier to simplify something down than it is to take something that's already simple and kind of build it up. It is doable, but it's more complicated. So you generally want to pick the side that looks more complex. That's the side that you're going to work with. Like I said, simplifying is easier than building something up to be unsimplified. All right, step number 2, if you're ever stuck, these are generally the things that you want to look for. A lot of algebra is going to go into this. So I know in our notes from the last class, we talked about a lot of algebra skills like factoring, greatest common factor, difference of perfect squares. We talked about all of our like fraction rules, like creating common denominator, complex fractions. All of those algebra skills are going to be important. All right, so here I listed out some of them for you, like things to look for, right? So it says creating common denominator, factoring, difference of squares. Sometimes you might find that you have a fraction, but you want it to be separate. So you have to, again, use like fraction rules. So that helps sometimes. And we might get to a couple on here where that might be helpful. No, today's is kind of easy. We don't have any where we would have one fraction we want to split it. We'll do that in upcoming days. But yeah, so remember, these are like your algebra skills that if you get stuck, these are things to kind of look for. Step 3 is to look for trigonometric things to do. This is where those identities come into play. So all those 14 identities that we talked about and went over in our last video, we're going to be definitely using those again today. Now, if you don't, I'm sure you don't. This is only day 2. But I was going to say, if you don't have them memorized yet, I'm sure you don't have them memorized yet, but you really should memorize them. Just like I said, we need to memorize our unit circle because it makes doing problems faster, right? If you're just using the unit circle, if you're just using the identity sheet and then trying to do the problem, you don't actually know your identities. And if you don't actually know them, then you can't understand what you have to do to kind of get to where you need to go. I know that sounds very vague, but think about simplifying a radical, right? If you don't know your perfect squares by heart, then you don't really have a good idea of how to break up the number underneath a radical in order to simplify it. So you have to know the information first in order to understand what you're trying to accomplish. All right, so main idea, you should be memorizing those trigonometric identities. It's important for getting better at these different proofs. Okay, and then like the last step, the last kind of thing that you want to do is make sure you always remember what your end goal is. So if you say you pick the left side of the equation to kind of simplify, remember what your goal is. Your goal is to get what you're working on to look like the other side or that right side of the equation. So if you start going in like a circle, because sometimes these ones you'll start working in and you'll end up going kind of circular, you need to kind of then think about, okay, what am I trying to accomplish? What is that other side of the equation that I need to simplify down to? And sometimes that can help. All right, so these aren't really steps. They're more like tips and tricks. The only one that's actually a real step is the step number 1. You have to first, before you can do anything, choose the side that you're working on. Okay, so I'm going to go through this. I'm going to probably do this whole front page. That way for homework, you really are only doing the back. Now, the way that I'm going to do it is not the only solution. There are multiple ways to solve these proofs. Okay, so if what I'm doing, say you thought of a different idea, well, that doesn't mean that your idea is wrong. As long as you're only using, the right trig identities and you're doing the correct algebra, then you probably have found another way to do it, and that's okay. Every year, sometimes a student will come up and they'll find a better way to do it than I did, a faster way. So there are different techniques out there. Really, you're doing what helps you best, which is one of the things that does make this kind of challenging to teach, is that everyone's brain thinks a little bit differently. So the way I'm solving something might not be the way that you want to solve it. And that's okay, as long as you aren't breaking any rules to do your technique. All right, so let's just go through a couple of these. All right, so number 1, like I said, we want to pick a side to work with. It's going to be the more complicated side. So I'm looking at this one in problem number 1, and I think the left-hand side looks a bit more complex. All right, so that means I'm going to work with the left-hand side. All right, so like I said, my goal is to make the left-hand side look like the right-hand side. I'm not solving. I'm not trying to get x by itself. All right, we will get to that part, but we're not there yet. We'll start solving end of next week or the week after, I think. All right, but we aren't at solving yet. We're just trying to manipulate our trig expressions is really what we're doing. Okay, so I have cosine times tangent. My end goal is to get it to look like sine, or to be sine of x. All right, so I'm just going to start using my identities and see what I can do. The first thing I see is that I have a tangent. Tangent can be rewritten as sine over cosine. So that's the first thing that I'm going to do. So I have cosine of x. Oops, that's a little bit. I'll use the blue one. Cosine x times, and then tangent is sine over cosine. So sine x over cosine x equals. Now I'm going to leave it blank. Some people like to put the sine x right there so that they remember that and they like to keep it with them. Some people like to just put the equals and then put the sine x at the very end. It doesn't matter. The one thing that you can't do is you can't work sideways. So I am going to be very particular about how you write your proofs. We only want to work vertically. All right, we do not want to work horizontal. All right, because things get lost that way. You either skip steps or you miss things, or Miss Lastly can't read your writing and it goes very awry. All right, so we only do proofs vertically. If you do your proofs horizontally, you will lose points even if it's correct. All right, so we want to stay vertical. All right, so our first step, I changed tangent to sine over cosine. All right, my next step is going to go below that. All right, so I see that I have cosine over cosine. I can simplify that. So cosine, oops, that was the eraser. Didn't mean to do that. So we have cosine over cosine. That simplifies. So I'm left with just sine x. Well, that's what I wanted it to be. So I am done. I have now made the left side look like the right side. I have proved that they are equal. So we're done. That's it. That's what we're doing here. All right. We're going over to number 2. Again, we start by picking the side we want to work with. All right. I think, again, the left-hand side looks a bit more complex, so I am going to work with the left-hand side. All right. Our goal is to get cosecant times tangent to equal secant. Okay, so I'm going to start by really a good technique. So I did this in number 1 also, and I'm going to do this again in number 2. A good technique, you may want to write this down, is when it's possible, change things to terms of sines and cosines. Get rid of tangents, get rid of cosecants, get rid of secants, because most of the time it does make it easier if everything is just in terms of sine and cosine. It doesn't always work, but it's kind of a nice like pro tip, I guess. Generally, it's going to be more helpful to do it this way. So I have cosecant times tangent. Again, I'm going to write this into, I'm going to change everything so that it's in terms of sine and cosine. So cosecant is 1 over sine x. And then tangent, like we just did before in problem number 1, can be written as sine over cosine. All right, and again, I want this to equal secant x. All right, now like before, we can simplify. So sine simplifies out. So what we're left with is 1 over cosine x. And again, we want this to equal secant x. Well, 1 over cosine, the reciprocal, so we're using our reciprocal identities, is secant x. So 1 over cosine does equal secant x. And now we are done. Check. Secant equals secant. All right, so pay attention to how much I'm writing. This is how much you should be showing in your work. All right, I know these first 2 are pretty simple, but you do need to show all of this. All right, you're not, a lot of times when we solve equations, right, you can do a lot of stuff in your head, and most of the time I don't really need to see that, because as long as your answer checks out and you showed a little bit of work, enough for me to know that you didn't just copy the answer from somewhere randomly, it's usually good enough for me. This is not that kind of situation, because the work that you're doing is the answer, right? We already know, like for instance, number 2, that these 2 sides of the equation equal each other. So I'm not really trying to get you to just set them equal, like say secant equals secant. That's not really what you're being graded on, because you already know that. What you're being graded on are the steps on how you got there. So you're getting graded on your thought process. So I do need to see all of the work. I need to see the thought process. All right, so those of you who don't usually show that much work, this is one of those times where you will lose points for not showing that work. If you skip steps, I can't follow that thought process. I need to see everything that you're doing. So you do need to show all of that work. All right, so just kind of keep that in mind. All right, number 3. All right, again, this is just coincidental that all of these tend to have the left side being the more complicated side. It's not always true, but for these ones, it does seem to be true. So the left-hand side is definitely the side that it looks like I want to work with, because 1 is going to be pretty hard to work with on the right-hand side. Okay, so I want to get secant times cotangent times sine to equal 1. All right, again, I'm going to rewrite everything so that's in terms of sine and cosine. So secant is 1 over cosine. All right, cotangent is cosine over sine. And then sine is just already sine, right? All right, and this needs to equal 1. Okay, so there's a lot of stuff that I can simplify here. Cosine over cosine simplifies. And sine over sine simplifies. Well, that was easy. All we're left with on the left is 1, so we have 1 equals 1, check. All right, and that would be an appropriate amount of work. You don't need to show any more, that's it. That one was really quick. All right, number 4. Again, I'm going to be working with the right-hand side. All right, so I have cosecant, tangent, and cosine has to simplify to 1. This is going to be pretty similar to number 3. Again, I'm going to write everything in terms of sine and cosine. So this is going to be 1 over sine alpha times tangent is sine alpha over cosine alpha times cosine alpha equals 1. All right, so we can simplify sine over sine, cosine over cosine, and that gives me 1 equals 1. All right. Let's see. We'll do number 5 also, and then maybe one on the back, because I think the back has a couple that are a little bit more challenging. Yeah. All right. So, number 5. Okay. So, again, all right, it's helpful to write stuff in terms of sines and cosines. All right, so I have sine squared. All right, secant is 1 over cosine. Cosecant is 1 over sine. All right, well, I have a sine squared on top and I have a sine on the bottom. So I can simplify, get rid of the sine on the bottom and then get rid of one of the sines on the top. That leaves me with 1 sine over cosine, right? We want this to equal tangent. Well, sine over cosine, that's one of our identities. Sine over cosine does equal tangent. So we have tangent theta equals tangent theta. There we go. All right. I'm assuming number 6 works pretty similar to number 5. So I'm going to let you guys work on that one. All right. And then let's go to the back. All right. I think I'll just do 2 on the back. Let's see. Some of these are some algebra stuff. I'm trying to see which one I want to do. I don't want to do all the fun ones. All right, I'm going to do number 7, I think. All right, so number 7. Looking at the left or right-hand sides, this one's kind of in between. You could go either way. My argument is that sometimes it's easier to, so if you look at, so on number 7, the left-hand side is 2 terms. The right-hand side is technically 1 term because you don't have a plus or minus. So I would argue that the left-hand side is more complex than the right-hand side because it's 2 terms instead of 1. So I'm going to choose to work with the left side. Now I think you could still easily do this one by working with the right, but for me personally, I think it's going to be easier to choose the left-hand side to simplify to look like the right-hand side. All right, so first thing, I'm going to change everything to sines and cosines. So cotangent is cosine over sine, plus tangent is sine over cosine. And I want this to equal cosecant beta secant beta. Okay, so this is a fraction, all right? I want to combine it so that I have just 1 term instead of 2. So the first thing I have to do if I'm going to add fractions is create a common denominator. So I'm going to multiply the first fraction by cosine beta, top and bottom. And I'm going to multiply the second fraction by sine beta on top and bottom. All right, so I have cosine times cosine is going to give me cosine squared beta, plus sine times sine is going to give me sine squared beta, all over cosine beta sine beta. All right, and I want this to equal cosecant beta secant beta. Okay. So now I'm here. So now we need to use an identity. All right. So if I look at the top, anytime you have something squared, if you can't figure out anything else to do with it, generally it's going to be one of those Pythagorean identities. So if you see something squared, it might be a Pythagorean identity. So cosine squared plus sine squared is one of our Pythagorean identities. It equals 1. So cosine squared plus sine squared equals 1. So I can replace this whole top piece with a 1. So now I have 1 over cosine beta sine beta. And I want that to equal cosecant times secant. Well, I can separate this, right? So 1 over cosine times 1 over sine. And I do that because that's going to give me, now I can easily see my reciprocal identities. 1 over cosine is secant. 1 over sine is cosecant. All right, now it's almost the same as the other side, but it's in the wrong order. So now I'm just going to use my, what is that? The associative property, commutative property, whichever one lets you, with multiplication, change the order, right? So now I'm just going to rewrite it, cosecant beta times secant beta equals, and now it's equal. Now it's the same on both sides. Check. Okay, I think that's pretty good for examples. I want you guys to work on the rest of them. They don't look too bad, if I remember correctly. There are some where you have to do, you know, factoring, or it looks like there's a few where you're using the distributive property. But you're doing the same technique, right? So you pick a side and then you just start working with it until you can get it to look like that other side of the equation. All right, but that is it for our video. We will